Eyepieces fam, how's it going? Coming at you with all the bugs on my screen. So many bugs. I don't want to kill these little guys, but what can I do? Get out of my face. Yo, what up Joey? What up Vision? What up Ashara? Morning to y'all. Got some beautiful clouds going through right now. I feel like... Let me know if the audio is coming through okay. Is that cool? I feel like something's crackling. What's crackling? Alright. We're gonna get some cool moon shots. That's pretty sweet. Yeah, I feel it is crackling somehow. I think it's logic. I'm gonna have to reboot it. Let's try that again. Alright. I think the crackling is gone. There's probably some MIDI issue. Give me a thumbs up in the chat if it sounds okay, if it sounds balanced. I'm not gonna talk too much tonight, just chill with y'all with this really awesome Waning Crescent. My clock is on the schedule, so I got some energy right now. It says video output low on the stream dashboard, but it looks green on OBS, so hopefully it's not too crap. See a little bit of the dark side of the moon, finally, this phase. It's been a while. And it's just getting over the horizon. You kind of see the clouds. But just as soon as it clears, I'm gonna get it back to normal. Sorry, little bug. All right, just lots of noodling. It's getting clearer, looking nice. So I was reading more about this whole electric scarification thing, getting closer and closer to understanding it. I even started putting together a video today, just aggregating some of the better clips, things where you can see hexagonal craters, reading more on Ralph Jurgens, listening to more Thunderbolts Project videos. I know it's just my regulars here, but if you're seeing this video tomorrow, check out the description of the video for links to amazing EU channels, Electric Universe. Another opportunity to talk about and give shout outs to all those pioneers, Hannes Alfvén, and Halton Arp, Donald Scott, Thales Thornhill, Ken Wheeler, Charles Proteus Steinmetz, Oliver Heaviside, James Clerk Maxwell, and many others doing things early on, giving us a bit of a platform, somewhere to start. Alright, so let's check out some dark side. We got Stellarium up here. I think it's a 37 Crescent, but let me just check. 37.1, hell yeah. Vision says Mars has places exactly matching our Grand Canyon. Yes, it does, and man, it's pretty late, so I'm gonna try and get my thoughts together, but the whole kind of the stratification, the kind of cuts into the mountain, the dendritic ridges are really intriguing. And they were talking about how Billy Elverton was doing plasma discharge in the lab with Michael Steinbacher, kind of throwing him ideas on what to do. And really, Billy Elverton has the craziest videos, really the raised mounds, and he has kind of the flat-floored melted craters, the little blueberries. So I'm trying to aggregate a bunch of that stuff where it's CJ Ransom, it's Billy Elverton, it's the guys who are doing it, Electric Universe Eyes, and this guy Electroterra, man, I really gotta get this name down. Electroterra Vision. We just gotta get some high-def cameras, really, and put all those clips together. And then I was also looking up all these different experiments of ballistics in the laboratory and high-speed impact, and you can clearly see that it has nothing to do with what we're looking at on the moon. The moon, if anything, is volcanic, but even that, you have to think about the geometry and how that was really formed, and really it's diffusion growth, and it's crystal lattice. And so I feel like we're really looking at something amazing when we do lunar geology. It's just been staring me down the whole time. Yo, what's up Globus? How's it going? What's up Z-Proxy? Vision says I watched videos on this over 20 years ago. This should be major science by now. Yeah, man, I mean, I'm really late to the party, for sure, but I don't know, doing what we can. I think there's a lot to do with marketing and a lot to do with how things are phrased and how things are filmed and presented. You see Thunderbolts like has some momentum because of the production and the consistency and the tone they take, but they also don't do enough, you know, in terms of what's happening on YouTube now to go viral, so to speak. And then we're inundated with misinterpretations of a ton of different science. And then you think about like what I was talking about like a few nights ago, the whole apologists, and just the idea that There's a whole swath of people that feel it really necessary to spend tons of resources on not new science and new experiments or actually looking at space, but actually defending old paradigms by what is proven to be a government that acts on its own accord. It's really funny. What's happening? All right. So I want to see the dark side. That's what I was trying to do. I'm not going to neglect the moon right tonight. Definitely got some haze. Yeah, that's going to be a bit tough to see. Yo, what up, bon dia? How's it going? Morning, astronauts. Exactly. So it's a bit too hazy to see the dark side, so I'm going to just zoom in on a couple of craters and take a look at the electric nature. Alright, so things I've been noticing. Thank you and welcome. So, it is easily confused, this whole idea of impact versus electric discharge. But I think when you look at these rays, the RAYS that come off the craters, you can kind of trace their lines back to the center, but a lot of them don't actually trace back to the center. And that's really a key point here. I think not that they're necessarily parallel, but if you can take a look at the bottom left corner, like the 7 o'clock ray coming down off of Kepler. This is Kepler crater, by the way. I need to adjust the settings a bit. Lots of noise. Yo, what's going on there, Tom? How you doing? Alright, I think the quality is looking okay. Tiny bit grainy. But there have been storms all day, so the atmosphere is definitely wet. So looking here at Kepler, this idea that if you trace these rays back, you'll see that they don't actually merge to the center point of this so-called impact strike. And that happens the same thing with that long extended ray coming off of Tycho crater, which I talk about all the time. So you can take a look at that as well. Ooh, fast. Am I crazy? Is Tycho already out of view? Well, that's fine. I guess Tico's already off the list for this moon. It was yesterday. I'll keep the camera here over at Aristarchus, top left, and Kepler in the middle. Two very interesting features when it comes to the whole electric discharge paradigm, and how Aristarchus was formed and why it's glowing so brightly is really a key feature here. I've been trying to kind of get information around Aristarchus, but I realized that Thunderbolt's project was really actually referencing a lot of the Ralph Jurgens paper that I read last night. So maybe I'll touch on that again. Got a squeaky chair tonight. Nice, Bomdia. You do any imaging, or is it all optical? Yeah, it's a bit hazy right now, but I think we'll get some detail shortly. It should look really nice tonight. I really like this angle of Aristarchus, and especially Kepler. It's like we're looking at it from above. But here's a fascinating note, so I've been working on kind of this whole hexagonal crater thing, hexagonal features, and you can see really the kind of indentation around Kepler crater actually starts to form a hexagon. So of course it's dimming as I talk about it. Let's get this a bit brighter. Actually, I'm going to do a wide shot real quick, get this nice haze, cool mood shot of the moon while it moves through. Yeah, nice, Bomdia. So are you doing planetary stuff as well? Because yeah, scoping is just one of those things that's just wonderful. It keeps giving you new opportunities, new expanses. And so going from optical to filming or recording is going to be really a nice jump. Okay, so I'm pulling just a couple of my notes up about craters and some of the points that they were making in terms of impact versus electric. And so you have the idea of central peaks. So we see a lot of those little pyramid and little isolated mountain ranges in the center of craters, and you see the flat-floored craters a lot, these kind of like melted wax or whatever molten floors that have cooled, and then this kind of triangular shape in the middle, and then the high-rimmed circular rim. So that is one of those things that scientists or pop sci points to in terms of that, you know, the impact created the central peak, because it created kind of a dip in the center and the impact kind of shot up from the middle. But when you really look at it, you'll realize that things like that are not really possible because the analysis has been done of these central peaks, and you realize that this central peak actually is the same material as the rim around it. So it's not something that really got ejected from deep down in the surface, nor is it from an external source. So that's a big sticking point that in the debate over central peaks occurring preferentially in large and small craters. Yeah, it's going through another kind of cloud layer right now, just like it did last night. It was kind of teasing, so we'll see if it gives us a clear shot tonight. Also, what up, fast paced? Yeah, right now getting Jupiter and Saturn basically all night, which is an amazing opportunity. Vision says, I think it is more liquefaction, more so than it being lava. So Velikovsky mentions kind of this whole idea of bubbling, you know, that it's all blistering, not just the moon, but other planetary bodies and Enceladus and others like that. So I feel like that actually makes a lot of sense in terms of the visual that we see on the moon, the kind of surface that is constantly overlapping these mostly circular looking craters. However, when you really search for hexagonal craters, it's very interesting that nothing really comes up on it. I found some deep papers written about the possibility of hexagonal features being recreated in a laboratory simulation, but the pictures are just like there's this tiny little slide and it really looks like a water splash, and it does not look like the striations we see on Kepler and Copernicus, and least of all Aristarchus, those kind of dendritic network filaments coming out. What's going on, Michigan Woodland Warrior? How's it going? And everybody joining. I know it's a bit kind of mushy on the clouds, but I'm gonna stick it out. I got a bit more energy. Go to like 4 maybe. So yeah, what's really fascinating is there aren't, you know, very many hugely apparent hexagonal craters on the moon, but there are several that you don't even consider until you really stare at them and you start putting like the geometry next, the side by side. So Ptolemaeus and Copernicus really like are very hexagonal. And it's just an amazing thing to kind of consider what would actually create something like that. It would have to be a prolonged effect versus an instantaneous impact that created this kind of mound. So Copernicus, Aristarchus, Kepler, likely Proclus, likely Tycho, and other so-called craters like that. Or, I mean, craters is fine because it's like a craters pretty much mean bowls, but these things are almost like flat-floored. I don't know, there's got to be a better word for it when you think about it. All right, it's getting a little bit clearer. So looking at the bottom right, you kind of see the elongated looking craters, but those are actually circular, mostly circular. However, what I want to note tonight, which I can zoom into in a second, is the almost hexagonal diamond shape of the indentation surrounding Kepler crater, which is really not referenced anywhere in lunar analyses. So just as soon as it clears up a little bit, but even now you can look around it, it almost looks like an eye, but it's really sharp geometry creating those angles around Kepler. So not only do you have nested geometry, but you have what are called rays coming out that look like filaments coming out of a neuron or neuro, like seedling. And this is sort of what happens when you see electric discharge in the laboratory and vacuum experiments. It creates effects that seem much more akin to what we're looking at versus this idea of a ballistic offset incoming trajectory, meteor or asteroid. And even though the references do talk about the fact that, there's the big question about why are things so circular on the moon. And that's why I thought it was so funny that I was very specific about hexagonal craters, and it kept giving me these articles about how circular things are. But in fact, it made me think that really circles are not circles at all. They're really just tons and tons of little straight lines going around, connected. And so the more little lines you have, the smoother the circle appearance. But in fact, so hexagons can kind of really feel like they're circular, but they're, at their core, they're just, those straight sides. Yo, sounds good, fast-paced. I appreciate it. Have a good one. What's up, Buried Axeblade? So late, I was supposed to be gone at 12, oops. Yeah, so I'm pretty set on this whole electric scarification of the moon and figuring out how to put just a compendium of sources together and good examples from all over the place and really show the dendritic nature of the sinuous rills, first of all. The main one being Schroeder's Valley inside the Aristarchus Plateau, and then looking at Aristarchus Plateau, the indentation around Kepler, looking at the kind of nested, the deposits in Mare Imbrium and Sea of Serenity and Sea of Tranquility. I get stuck trying to figure out which I'm going to say, Mare Serenitatis. But, kind of the nested greens and blues that we see, and kind of turn up the color on that. But I'm just thinking, yeah, so it's so you do stumble across those basalt columns, those very tall columns that are essentially honeycombed, and they just appear in nature. And so you have this either nature searching for either path of least resistance or strongest geometric shape. And on top of it, you have the ability for nature to separate itself and create these kind of structures without influence. However, when you have something that explodes, you have such erratic nature to it, and kind of the thermodynamics of it strew debris everywhere, and you have these remnants, and you have irregular circles. You don't have these perfect geometric shapes that look scalloped, really, and don't have dendritic ridges. So it's really key. Got some full cloudage right now. What can we do but turn up the gain? It is really biological, actually. That's probably how cells kind of grow from a particular point source, right? Or they start kind of squeezing each other out and creating more and more, and they have adjacent walls. And some of them are 5-sided, some are 8-sided, some of them are circular. And they kind of bubble together and they create this reaction diffusion pattern. and nested fractals. You know, you zoom out and you see the arrangement of them, and they kind of all merge together to create a shape. And you zoom out again, and you have a totally different pattern to it. It's kind of the same within our body, and it's probably the same in space. And it's likely the same as the kind of environment around the moon and other bodies. I kind of, man, every time I think about it, I'm like, I wish we could do Ceres. I wish we could do other, you know, asteroids and see them up close, but it's not really a possibility. Right, so we had central peaks. The other one was small craters perched on the rims of other larger craters. So you see that a lot. You don't see almost any, if at all, large craters on the rims of small craters. So like a whole, you just see a small crater and then a huge crater kind of cutting it or destroying it. You don't see any of that. Further, I don't know really how to articulate this perfectly, but I've seen people talk about electric discharge and the arc trying to find the high ground, I guess. And so it will create this kind of larger crater and then move towards, I guess, or even if it actually won't even move, the actual plasma current or filament will actually create this kind of tangential or adjacent secondary crater or secondary feature. I could be explaining it wrong, but something like that. And the flip side is impact craters just would have this crazy statistical anomaly for them to hit larger craters at those types of preferential, just literally on the rim of larger craters. So it'd be highly anomalistic. Jeff Gibson says, I didn't choose the plasma life, the chasma. The plasma life chose me, dog. Yo. I mean, it's one of those life-changing experiences. Once it just hits you, you're like, damn, people have been thinking about this for this long? It's crazy. Yeah, I think my frame rate is acting all whack tonight. I don't know if I have my settings perfectly right with OBS just yet. I noticed last night's stream was all janky and pixelated, so I think tonight I got the quality up, but the frame rate is acting stupid. I can see it kind of being jerky. I don't know if I should even try and mess with it at this point. But if you all can hear me and see a clear shot of the moon, that's enough. And then tomorrow I'll test it and get a little bit better. I don't know, I guess I can try and change it on the fly. Let's see, if it breaks stream, it probably won't be too bad. So profile, ultra fast, very fast, main. Let's try this, see if it gets any better. So yeah, so central peaks, right? Small craters perched on the rims of other craters. Then you have electrical arcing and the fact that the moon doesn't really have a very thick atmosphere. So you'd have to think about either Mars or Earth or some other planetary body coming within a really close distance of the moon to be able to create this interaction. So there is, there are leaps to imagine when it comes to electrical discharge exchange between planetary bodies, but just fundamentally it makes a lot of sense. So you allow for thoughts like that to occur, because of course we don't really fully understand gravity, and we fully don't understand mass or matter for sure. As far as I can see, people have a ton of different opinions on it. And so we don't know if planetary bodies can actually come closer without their electrostatic charge really. I mean, the effects really would be plasma exchange. So things would be occurring if two planetary bodies came close. Okay, so what's the third? That's 3. The extreme circular nature of the craters means an object needs to strike from directly above, right? So there's this whole idea that impacts come towards the moon and then blow up over the surface. They don't actually impact exactly directly the surface, so they create this kind of circular impact crater. But they argue so strongly, or PopSci argues so strongly for that they never really mention that they're actually hexagonal craters, and where did those come from? So there is some idea, or there is a debate about like why craters are circular and how impacts could create these kind of caved in craters that we see. But I don't know, you really look at the flat floored nature of them, things like Sinus Iridum at the top left right now, the feature that's just barely showing, even that has a tiny little crater exactly on the rim of Sinus Iridum. I can't tell if the frame rate got a little bit better, maybe it got much worse. It looks smooth on OBS, but then I'm looking at it on my dashboard and it looks pretty jank. So I'm sorry y'all if it's not really smooth tonight. I know I've had that problem in the past, it's just I have a new PC and I'm just getting OBS settings right, and it's not always easy. Okay, what else we got? Extreme circular nature, then dendritic ridges, right? So dendrites are kind of just like little branching pathways, that we see on mountain sides, kind of striations and almost snake-like features cut into rock, or the way rock is formed. And so you see, I'm making an allusion to the fact that like a ton of craters on the moon have these high rimmed walls around it, but they also have these kind of dendritic cliffs and mountainsides coming down towards the middle. I'm thinking of Plato, thinking of Tycho, I'm thinking of like Posidonius and Gassendi. I wish I could show all of these, but clouds are not making it easy tonight. No buried axe blade, it's just that I think OBS is not sending out 30 FPS, it's sending out like 10 FPS for some reason. Everything looks green, but I run this 4K camera into the AVIO capture card, and there's a very particular setting for OBS for it to actually run 30 FPS out to YouTube. I had the same issue like a year ago when I first got it, and now I set up the new PC and it's doing the same thing. So it's getting clearer. You'll see that the clouds are just shifting a little, ever so slightly, like they're not really super smooth. And I just changed the setting, and I'm not sure if it got any better. Buried Axe Blade says, how deep are the moon's craters? So it depends on what you mean by deep, right? So like if we're seeing the flat floors of the mare, considering that that's 0, right? The craters themselves don't look like they're much deeper than the mare themselves. So the walls of the craters, the kind of the rims, those are like 12,000 to 14,000 feet, maybe 20,000 feet in certain areas. Like think of like Sinus Iridum at the very top left now, that's like 12,000 feet. Yeah, those clouds are Earth clouds for sure. That's atmosphere. At least we're seeing a little bit. I'm gonna try and change the video settings one more time. Output, enforce settings. Let's try 10,000 bitrate. Alright, maybe that'll do. Vision says check the keyframe setting. Keyframe. So I'm in settings and I have output. Oh, keyframe intervals. What should I put as that? Should I put 0 says auto. Maybe I'll do 2. I don't know, I'm messing with this. But what's the worst that can happen? It'll just reconnect. And the moon's getting a bit clearer as it rises. I really want to get a zoomed in shot. So you see Copernicus is being cut by the Terminator right now. That's a really dope little shot. And we can see, it's not the clearest hexagon, but Copernicus is a great example of your eye, you're doing the trick on you, looking at a hexagon being like, no, that's a circle. But yeah, this is not a great example right now, but it does look super cool. I mean, look at this kind of strata. This doesn't look like ejecta at all. This looks like a lot of sharp little geometry. And it almost has network organization to it. This is right on the rim of Copernicus crater, which is also incredibly cool. But it needs to restart, huh? Yo, what's up there, Super Must See? Yeah, I want to show this a little bit better. Yo, if y'all can hear me, I'm gonna just reboot OBS and I'll stream right back over here. So maybe it just will continue. Hang in there. I'll be right back. It seems like I just ruined everything, but the moon's looking really clear, so I'm gonna try this one more time. Let me adjust the settings and see if it gets it right. Fun and games at 4 in the morning, love it. Alright, let's see if that works. No, it says video output low. It's just a total mess tonight, y'all. I'm sorry. I tried to test it, but this is what happens sometimes. I'm just moving it from side to side to see how smooth the frame rate is. Oh man, it looks pretty terrible. I'm just gonna try one more thing, one more time. So none, fast. I'm just gonna try and regulate this thing. Alright, I'm going to reset this one more time. I'll be right back. And if not, I'm just going to chat over a jittery moon. Be back, y'all. Thanks for your patience. Alright, I think it might have worked. Let's see. I think it might have worked. Ooh. Cool. It looks semi smooth. So while we got it, let's zoom in on our moon. Actually, let's take a look at the dark side first. I guess not, it's too hazy, but at least it looks clear. I'm going to zoom in a bit more, take a look at that Copernicus setup I was talking about. Welcome back, everybody. Thanks for your patience. Let's pull up an old school track. Here we go. Also, what up, Justin? Okay, so we got a nice clear shot of this super cool region to the left of Copernicus crater. I know it's dropping a few frames, y'all. I feel like the settings are not perfect yet, but so this mountain range that we're looking at right next to Copernicus is called Montes Carpatus, and then Rima Draper, and you got T. Mayer as well. And the darkened crater I want to say is, what is it? I think that is the T. Mayer. It just looks very different because of the flip. Angry crackpot, exactly. And you're just seeing all this kind of layered strata around Copernicus crater. Another great example of kind of the layered, what is supposed to be ejecta, actually really being layered, just pushed out land from this kind of amazing, huge blast discharge, kind of pushing out everything from the center and creating what really is a hexagon. And next time we get a chance, we're gonna, on the next moon cycle, I'm gonna get a bunch of shots of Copernicus, really focus in but I'm looking at it on the atlas and it's for sure hexagonal. Alright, so I got a lot of screens open. Just let's zoom around a little bit. Take a look at that other feature I was talking about around Kepler. So actually Kepler seems to be like a highlight feature tonight. Maybe something a little more chill. I really gotta write some new stuff that's a bit more background music. But anyway, got a beautiful shot here of Kepler. I know it's jittery as all hell on the stream. I think it just keeps getting backed up. But thanks for hanging out with me. It's 4 a.m., 4:04, but no error. These are electrical craters. Dad joke. We got tons of sinuous rails, kind of, what did they call them? There's a name that I saw earlier that just seemed so silly. They're kind of snaking overlays in the regolith. It's almost like land slumps, but it also could, it almost looks like shorelines as well. So that could also be a remnant effect of electrodynamics pushing out these kind of oceans of iron, right? I don't know if it was really molten in the way we think about it, but perhaps. I saw a little reference tonight to this, to Clash of the Titans, and it dawned on me that Perseus is actually just of Zeus. Never even thought of it. So if Perseus defeated Medusa, and Medusa is supposed to be the comet Venus, then is Perseus really a representation of Ares, of Mars, or different, you know? And then if Perseus is actually the son of Zeus, so did Jupiter emit Mars to defend against Venus? That'd be interesting. I'm just talking, just read that today. What's going on in the chat room? Y'all tired? Or what's up? Or is it totally glitching? I feel like it looks like it's glitching, but hope it's tolerable. I'm just gonna record some of this footage just for the sake and put it in the videos later on. Yeah, so where does the moon fit into that story? So there's the whole idea that Homer wrote that the moon and Mars were actually kind of tied with a gossamer filament that seemed extremely fine and delicate but unbreakable. And so perhaps Moon and Mars actually did a dance and had a plasma exchange, and therefore when they separated we were left with this moon that was scarred by its interaction with Mars. That's just one way to look at it. Man, the picture is real clear. I feel like the settings, I'm gonna have to get them right tomorrow or for the next stream. I wasn't even anticipating staying up this late tonight, but I made it. Like I said, one of my favorite phases of the moon, you get to see Sinus Iridum up top, you get to see Kepler in amazing relief. Aristarchus is obviously at an interesting angle. Let's zoom in and take a look. It's extremely bright. So the paper that I read that Ralph Jurgens wrote was referencing all these different little sinuous rills that are located really predominantly around the Aristarchus region. And that's a very interesting line of questioning and consideration in terms of like what plasma arc was moving across this area, leaving little like sputtering and or microfilaments interacting with this region. It looks like it's super electrical, but so actually just hanging out right here, you can see a bit more of Aristarchus. This is actually a particularly interesting angle because you get to see Herodotus, a flat-floored crater to the bottom left of Aristarchus, in pretty good detail. Let's zoom in here. And so this as well, you can see Schroeder's Valley, the kind of sinuous rill that is one of the main carvings of electrical discharge. And in popular science, the only logical rationale that is postulated is that it's a volcanic lava tube. And so this thing runs about 100 kilometers or so, maybe a bit more. And you don't see any, first of all, it does this kind of thing where it's called goosenecking, where it kind of goes around and curves. So no lava tube really curves and goes back upland, uphill. And then two, you don't really see any of the lava tube collapsing, which is what you do see here on Earth with lava tubes, because they're structurally not sound. So this very, very sharply defined sinuous rill, Schroeder's Valley, in the center of Aristarchus Plateau, is a particularly noticeable feature of electric discharge. Vision says, if the moon was just a few miles closer, it would be arcing with the Earth just like it has in the past. I mean, essentially, like, it is probably in some sort of phase of plasma discharge between it and Earth right now. Its impact on really all the magnetism and the water here on Earth means that the interchange of the two plasma sheets must be really immense. Still, even though we can't see it as much as it would be if it were in glow mode, which would be very scary probably. Y'all, I'm so sorry for the crappy frame rate tonight. I kind of want to restart it one more time because we have some cool footage. Let me know in the chat if I should bother resetting it one more time. I don't even know what the settings should be, but I could probably just go back to really low res. I'm gonna try it one more time because this sucks, I'm sorry. too cool to let it go. Be right back, everybody. All right, let's see how this fares, if this fares any better. Let me know in the chat. It seems like it's okay. I see green all around. Yeah, there's nothing else happening on the computer except for that and the Moon Atlas app. And this is like a super powered computer. Super. It looks green, everybody. It looks smooth. Let's do a zoomed in shot and see. Let's check down near where Tico would be. Look at this. Damn. This area is just beautiful. You see elongated craters. But you gotta wonder, like, are those actually really elongated or are those stretched because of the moon's curvature? Yo, what up, Yo Q? I saw, what's it called? Wolfman Jack left me a comment. So funny, I've been going back through all the old videos, liking some comments from last year. Damn it, as soon as we got it clear, we got clouds. Dang. All right, whatever, hazy moon, hazy, lazy moon. At least it's smooth. So I have to check if this is the right setting. Give me that thumbs up, let me know. I don't want some fries with that crisp. I want some fish with that crisp. Let me know if y'all are still with me. We're gonna take a look at Sinus Iridum, the funnest place on Earth. The funnest place on the moon. The finest. And you can see some really cool, sinuous things. Lots of sinus and sinuous. The land folds. So even the land folds, right? Let's say this is sloughing or slumping of the land, or the regolith, or the lava lamps, or the lava tube, the lava dance. You still have what it still looks like dendritic branching lightning bolts. It's so crazy how intrinsic electricity is in its form that you still see like just regular geological events exhibit fractal patterning that we can, just relate. So that's what is to the right of Sinus Iridum. And then you have to imagine, of course, the whole Sinus Iridum bay right now that looks like the kind of C shape had a whole other side to it that either got buried or that got pulverized, and that's crazy. Yeah, no, I haven't seen Wolfman Jack in the chat, not in a while, but he did, so I liked one of his comments from like 2 years ago, and he came on, left me a note on the last one. So people are around, it's just funny. YouTube is just, you just keep the counts open forever until an EMP from space wipes it all out. But we keep going, data bits to data bits. So look at this tiny little craterlet on the rim of Sinus Iridum. Of course, sadly, the Chang'e rover took one photo and then died. One really, really grainy photo. But damn, love it. Love it, love it, love it. How can you complain with a shot like this? So, so you gotta think like, I was typing in like Sinus Iridum or Bay of Rainbows formation, or Sinus Iridum discussion about the moon, or Sinus Iridum Apollo, and you get like really strange articles, you get a bit of conspiracy, you get a bunch of the Chang'e 3 rover stuff, but really nobody talks about like how the hell was this feature formed. It's massive, right? It's got this really very particular setup. It's almost visible with the naked eye from Earth. And it has all these associations and slumps in the land that kind of lead to different places. So I find Sinus Iridum particularly interesting. And everything I say at 4 in the morning is to sound drunk. But I'm sure you. Yeah, it's super sharp. I'm gonna do a little more research on it, but that's one of those key features. Moving up a little bit over it to Mare Frigoris. We got Anaxagoras cut by the Terminator. And this region has that kind of these, I want to say square, but really it's almost the same thing as kind of diffusion cellular patterning up at the top. And obviously it's kind of pulled because of the curvature of the moon, so it looks like it's stretched. But this is also the kind of cellular boiling of the regolith, essentially is how I look at it. It feels like that I'm repeating myself a lot, but it also feels like the video is smooth, so that's awesome. And we got some crispy shots right here, especially this kind of region right above Sinus Iridum. Let's take a look again at Kepler. That was pretty hardcore. Hardcore Kepler. Actually, before that, let's see that Copernicus shot. I feel like I should really just switch up the focal reducer and get a bit closer. A bit closer, everybody. I'm gonna do that, and I'm gonna play us one of these newest jams. Let's call that Grown to Like Ya. And I'm gonna switch up the focal reducer, we'll get much closer. Much close. Alright, so this is camera direct to the 11, and it's looking really nice. Coming up on 4:30 here. So what else was I watching tonight? I saw this, sometimes I'll check in on the sad state of current cosmology. And so I typed in deep astronomy with that cat Tony Darnell. And I stopped listening, of course, years ago, but I just check in from time to time. And I heard him talk about how disappointed he is with the whole Starlink satellite system and how it's going to just ruin astrophotography and space travel. And it's just said, and I find it so interesting how, you know, he has this massive platform, a couple 100,000 followers, and it's just really, he has such a tough time to getting off the fence about whether it's a good or bad thing. It's obviously a bad thing. And, you know, just lamenting the fact that commercialism is just going to move forward no matter what. And it likely is, but it's probably finally time to pick a side, which is no satellites. No more. Like, no more satellites. It would be nice. Because then, you know, then we can avoid stupid shit in 20 years, if I'm still around, where they're like, oh, we should have never put all those satellites up there. Now we've ruined it. At least I said it now. Anyway, we got a cool moon. I'm getting a little bit tired here, but I'll do a few more minutes now that it's clear. Highlights: Sinus Iridum, Mare Frigoris, Anaxagoras, Aristarchus, Kepler, and 1/2 of Copernicus. And I want to say that this is Mare, before I say it, Mare Humorum and Gassendi crater. And you can kind of see what's so interesting is Mare Humorum is a ring crater in a way, a giant ring crater, and then Gassendi is on the rim of Mare Humorum. And then on the rim of that is Gassendi A, which is a small craterlet. But that's just crazy. What are the odds of that occurring? Unless it's actually this organic growth system where things do occur on edges of other things, which seems logical. Yeah, so what I was mentioning earlier on the stream, I'm going to say it one more time, which is the fact that you can trace a lot of these rays coming out of the craters back to the point of impact, so to speak. You'll see that they actually cross, like they pass by the center, and that's really one of those smoking guns of not impact. You know, just because really you'd have it coming out of the center and you'd be able to trace these lines back, but in fact, if you had an electrical discharge, it would actually create a ripple from underneath this central, like, connector, and that really wouldn't have to stem exactly back to the center, but you'd get these kind of pointed rays and some parallel rays. And next time we get a different moon phase, we're going to look at Tycho and the long parallel rays coming off of that. And that's something I'm also looking into to see how, like, who's talked about it, what are the references to it, how do scientists think it formed. Not a lot about it, to be honest. Western Pennsylvania Skywatcher says decorating, quote unquote, the night sky with commercial satellites would be a disgrace to our civilization. I gotta say, man, I agree completely. Like, I mean, I would have completely agreed regardless of doing telescope work, but now that I do this so much and I'm obsessed with it, and you know, like I hear the passion in even Tony Darnell in deep astronomy, you know, like you can hear the sadness in his voice, but there's really almost nothing you can do about it. However, I think it's important to distinguish that some people are doing it, that it's not a we collective are putting satellites up, because I don't think a lot of people really want those satellites necessarily. I think they just go up, in fact, and people don't even know that they're going up, and people hear about it after the fact and they're just like, oh shit, I don't agree with that, but whatever, you know, now it happened. In a way, even I'm on top of that shit, and I sometimes miss like a dozen rocket launches. People are like, did you see that rocket launch? I'm like, no man, like, fuck, I was living, doing stuff. So I feel like we miss that, even if you're alert and you're gonna get all these satellite launches. But I think that whole being on the fence about whether it's good or bad, it's obviously like internet, sure, but what he was talking about is this whole kind of competitive landscape of Amazon and Google and Facebook each getting their own set of like 5G, 6G, Wi-Fi from space. But really what it's about is actually just private communication for private industry, for private military, you know, so on and so forth, not for really your average consumer. And so I think this whole backyard astronomy craze is actually kind of, I feel it's like it's been going on for a while, but now there's this new wave of backyard astronomers. The technology is really advanced. You can see amazing things from your home. So it's really a shame that we're entering this age where you have a whole bunch of people who are extremely rich who just want to keep taking over nature and then just blaming everybody else for it. And that's what I really need, like, have started to switch up in my life, is trying to understand like where I play my part, but where I'm also like, I'm completely against these satellites. Like, I don't think they should really, but where can we lobby? You know, where can we stop it? Vision says we launch a satellite every 3.2 days about. Yeah, that's crazy. I bet probably more that are not even public. But anyway, that's enough lamenting. We're looking at this gorgeous, gorgeous, unbelievable object. Sentient, probably hollow, magnetic, magic moon that day by day I think like has grown from a seedling and has now interacted with different planets in our solar system and is somehow really very peaceful looking to some degree. And you know, the American government insists that we sent men there, and I want to believe it. But I still go to bed every night thinking that it would be an amazing thing to see it happen today, and we should definitely go to the moon way before Mars if there's a collective we. But even private industry, and if we're just watching private industry do what they do, private industry should be like on the moon soon. I mean, Jeff Bezos, Elon. I think there's this whole there's a whole video that came up in my feed where Elon says something that is going to be probably making the rounds this week, but where he mentions that he doesn't think that the US can get into low Earth or can send people into LEO, which is pretty fucking unbelievable. I mean, I know it sounds very whatever, like, oh, gotcha moment, but it's more just unbelievable that that's the case. If it's really real and that's how the situation shakes out, that America can't get people into low Earth orbit like 40 years after a massive, unbelievable space program got people to the moon, that's just really crazy. I think that's the big story today. And how do you urge bloggers and faux pseudoscientists to kind of get on board with that? I don't know, but you keep making videos about better shit. We got some closing shots of the moon because I'm getting sleepy. Hope y'all have a great day tomorrow. It's Friday. I think if it's clear tomorrow, I'm going to do some Jupiter from the back porch, because tonight I missed it. It was during the dance of Io and Europa. I really want to capture like a 4-hour Jupiter shot where the moons do a flip around. That is the shot to get. Yeah, like Tony Darnell was saying, what is it, like 20,000 satellites? And then I know that Vision and I always have this dispute. I always feel like it's 1,500. I'm going to check it again and see how many satellites are up there. How many goddamn satellites exist in this multiverse? According to UNUSA, in history, a total of 8,378 objects have been launched into space. See, what is that about? So he was definitely saying something like there are like 20,000 satellites, but it didn't seem right to me. So in total ever is 8,378 objects have been launched into space. Currently, 4,994 are still in orbit, although 7 of them are... So it means about 5,000 satellites are whizzing over our head every day. And I think I read the statistics that like half of them are operational. So that's where we stand today. I don't know if that's true or not, but that's what the numbers say. I don't see any 20,000 anywhere. Yo, peace out, yo Q. Oh yeah, oh you're saying night to me, yeah, I know. But I'm looking at this moon and I'm like, I'm gonna let it ride for a few more minutes. To the end of this song at least, which is 5 minutes. Yeah, so electric scarring of planets, sinuous rills, really important features. Ralph Jurgens, Halton Arp, Thunderbolts Project, a bunch of others in the description to check it out. I know my regulars have heard that a million times, but if you're new and you're just stumbling across this video, go check it out. Thanks for bearing with me tonight with the technical stuff. So I feel like if this looks good on tomorrow's stream, then the settings are correct. I'm not going to touch them anymore. And then I'll probably do a Jupiter and Saturn stream over the next couple of days, over the weekend, and or come back with some moon in like a week or 10 days or so. Maybe take a little break and work on the clips. See, this is awesome footage right now. I actually saw a satellite by eye tonight, optically, when I was walking outside. Passed above Jupiter and then crossed. It would have been a great capture had I had the scope on me. say no to new satellites. Or at least there should be like a global committee where people can vote on whether satellites are necessary or not. It shouldn't just be willy-nilly. Because then you're gonna have all those stupid videos where it's like, oh damn, we screwed it up. We shouldn't have screwed it up. Why did we screw it up? And no one's gonna be like, I told you so. They're gonna be like, you don't believe in what I'm saying and you don't want to change things. But we should just learn from our mistakes. Mr. Musk. Mr. Government. Mr. Player. Anyway, it would be nice if we had a rocket going to the moon. I think the Chandrayaan is on its way, but let's see if we get some cool footage this time. Otherwise, we have to wait for another rocket to be launched with a GoPro on its hood all the way to the moon. Somebody will say, oh, but it has to spin around Earth a bunch of times before it gets there. That footage would be really boring. I'm like, I don't think so. I think that footage would be dope. See all the stars around Earth from a different type of perspective, and then see 5,000 satellites streaming by. That would be exciting. Space is really, the public space is very, very boring. Anyway, appreciate it, everybody. Have an excellent Friday tomorrow, and we're part of the most recent footage of space on Earth. It's always very comforting to know if somebody else on the planet is doing this. I hope they reach out telepathically and we'll share the moment together. Stay safe, stay wise, peace.